Good evening, students. Let us go for the 2025 January 23rd morning session physics paper, and let us discuss the paper. Here you can see the questions. The first question is related as units and dimensions and little bit electrostatics. The electric flux phi is related with linear charge density lambda, that is charge per unit length, and surface charge density sigma, that is charge per unit area, as phi equal to alpha lambda plus beta sigma, where alpha and beta are appropriate physical constants, maybe physical quantities are constants. Their dimensions are they are having, and the question is what will be the dimension formula of beta over alpha. Here, from the units and dimensions concept, if phi and alpha lambda plus beta sigma, if they are the constants, then let us go to this. Here, the dimensions of phi, dimensions of alpha lambda, and dimensions of beta sigma, they should be equal from the concept of dimensional formula. So let us go to that. Here, flux dimension same as alpha lambda. So electric flux dimension should be same as alpha lambda. Electric flux dimension should be same as alpha multiplied by lambda. And whereas if you go to the question, let me check it. The second one is beta sigma. So electric flux dimension should be same as beta times 2 sigma. And the question is, he is asked as the dimension formula of beta over alpha. So let me go for to get beta over alpha. Let us go for division of these two. That is beta sigma over alpha lambda. This is equals to electric flux dimension over electric flux dimension. So they cancel with each other, and remaining is beta over alpha is equals to lambda divided by sigma, and lambda is electric charge per unit length and sigma is electric charge per unit area. Area we can indicate with the dimension L square, length into breadth, and charge dimension will be cancelled out. 1 L will be cancelled out. 1 over L divided by L square over 1, that is nothing but L. So its a dimension same as length, and if you go to the question, it is same as displacement. So this is the answer for this question. Now let us go to the next question. In the next question, he given a velocity time graph, and it is a linear one like y is equal to mx plus c. The question is find the distance traveled up to 0.5 seconds. That is the question being total displacement traveled from 0 to 0.5 seconds, and this graph mostly will go for velocity vector magnitude given means it's a one-dimensional motion. So in one-dimensional motion we have to calculate total displacement traveled from 0 seconds to 0.5 seconds. And for this here slope is constant for this velocity time graph. Slope is constant, I mean velocity time graph slope is acceleration. So it is going with constant acceleration. Hence equations of motion we can apply here. So let us apply equations of motion, and before applying that, here slope of this Vt graph will be opposite side is 400 minus 200, that is 200, and adjacent side is 2 seconds. So slope will be 200 over 2. Now let me go for calculation of the slope. Here we can go for the acceleration, that is slope of Vt graph, final velocity 400 minus initial velocity 200 over time. So acceleration will be 200 over 2, that is 100 meter per second square. You can see the graph here 400 to 200. And second thing, when time t is 0, the initial velocity is 200 meters per second. So let us use that. That is initial velocity u is equals to 200 meters per second. and what we have to calculate is total displacement traveled in the one dimension motion from t is equal to 0 to 0.5 seconds. I can use from equations s is equal to ut plus half at square. Here initial velocity is 200 and time is 0.5. 200 into 0.5 will be 200 into 1 by 2, that is 100 plus half. Acceleration is 100 meters per second square and t square 0.5 whole square is 0.25 and 0.25 multiplied by 100, 25 by 2. So 100 plus 25 by 2 is the displacement, that is 100 plus 25 over 2 and 2 12s are 24, so 12.5 plus 100, 112.5 will be the displacement traveled by the particle from the graph. And let us go for the question. Here 12.5 yes, so option is B, 12.5. Let me go to the next question. In the next question, we given displacement of a particle as a function of time. Again, this is from units and dimensions. So here x is equal to a sin t plus b cos square t plus ct square d plus d is given. And let us go for this question. Here displacement of the particle as a function of time is given. Here the dimension of x, which is same as length, should be same as dimension of a. Sine function doesn't have any dimensions. Cosine square function doesn't have any dimension. So b dimension same as x, a dimension same as x, ct square dimension same as x, and d dimension same as x. So here if you check all these conditions, a dimension same as x, so dimension formula for a will be L, and b dimension same as x because cosine square doesn't have any dimension, same as length. Ct square dimension is same as length, so dimension of C will be L over t square, that is Lt minus 2, and d dimension same as x. Now let us go for the question whatever he asked. He is asking the dimension of ABC divided by D. So ABC divided by D is A is L and B is L and C is Lt minus 2 divided by D. D dimension same as L. Here one L we can balance. Remaining is L square t minus 2. So L2 t minus 2 will be the dimension of ABC by D, whatever he is asking. So this is the simple solution for this question. Option B is having. Now let us go to the next question. So for this next question, here ratio of electric force to gravitational force between two particles having charges q1, q2 and masses m1, m2 respectively is directly from the conceptual. So ratio of what we have to calculate first should be the electric force and then should be the gravitational force. So let us go for electric and gravitational forces. Electric force over gravitational force, and electrostatic is 1 over 4 pi epsilon naught. Only magnitude of the forces he is asking, so q1 q2 by r square, and gravitational force is g m1 m2. Our distance is r square. We can balance r square, and q1 q2 over 4 pi epsilon naught is as it is. It is a basic conceptual one, divided by g m1 m2. So g m1 m2. So this will be the ratio between them. And let me go for the solution, whether in the key it is 4 pi epsilon naught, it is q1 q2 by 4 pi epsilon naught g m1 m2. So that is the answer for this question. Now let me go for the next one. For the next question, it is a match for the following columns option. This is from thermodynamics. Here, when volume changes is zero, I mean here in general, work done by a gas in any process, we will go for integration of PdV. I think you know this. Whenever volume of the gas changes, that means piston is moving either up or down, then only gas molecules will apply a force, pressure into area, and in the direction of the force there is a displacement, then only work done. That means to do a work, the piston should move some displacement. That means volume of the gas either should increase or decrease. When volume changes are zero, then work done will be zero. So P will coincide with work done will be zero. And let us go to next. When pressure is constant, natural, it is isobaric expansion or compression. And when no heat is exchanging, no exchange of heat means here directly from adiabatic process delta Q is zero and work done by the gas is equal to heat given to the gas. That is same as in isothermal process, because in isothermal process when you check it, the temperature remains constant. In any process, change in internal energy is NCV multiplied by change in temperature. CV is specific heat capacity at constant volume. N is number of moles. In isothermal process, temperature remains constant. So change in temperature 0. So change in internal energy 0. Then heat energy supplied to a gas is increase in internal energy plus work done. This is from first law of thermodynamics. When change in internal energy is 0, mechanical work done by the gas is equal to heat absorbed by the gas. So this coincides with the option. So here yes coincides with the 4. Then this will be the very simple question. So P suits with the work done 0 and this for isobaric and this for no exchange of heat adiabatic and this is isothermal. A simple theoretical question is that. Let us go to next one. In the next question, in given DC circuit, I mean there is no variations of electric current, a constant potential difference from the source is applied. So this is a constant potential difference, 12 volts is applied, and here the question is find the current through the when the resistance offered is 12 ohms in the rheostat in steady state. This is an LR circuit, growth of current in the circuit connected to the battery, and in LR circuit in steady state the EMF induced across the self-inductance will become 0. That means minus L di dt will become equal to 0 and a constant current flows in the circuit. When a constant current is flowing in the circuit, when no EMF is induced here, then only an EMF because of the source and a potential difference because of the resistance, only these two exist and a constant current flows in the circuit. Because there is no potential difference, I can write the total potential difference 12 volts is equals to the current passing through the resistance multiplied by R. So here current is equals to resistance is 12 ohms. So electric current will be 12 over 12, that is 1 ampere. This is also a very simple question. No need to worry about this. So answer is 1 ampere for this question. And let us go to the next one. This is an assertion and reason type. Hot water is less viscous than that of cold water. When temperature is increased, then due to thermal expansion, the gas molecules will expand, space between the gas molecules increases. then attraction forces between the molecules will little bit decrease. Sorry, this is the hot water, it is in liquid state. When due to the thermal expansion little bit, when the space between molecules increases, the attraction forces between molecules will decrease. When the attraction forces decreases, viscosity force decrease. In general, viscosity in liquids is inversely proportional to temperature, hence hot water less viscous. So first statement is correct. Surface tension of soap bubble is more than that of a drop of water. Surface tension depends only on nature of material. Here soap bubble and water, if both are filled with water, if the amount of soap quantity is negligibly small, then surface tension remains same. So he doesn't mention how much soap water is added to it, and in the soap bubble is also inside an air and outside an air. These two are boundaries covered by water only we are considering. So for same water, surface tension should remain same, only excess pressure are different. So second statement is a wrong statement because the soap bubble consists of water and a drop of water consists of water. So in water, for the same material, surface tension is same. So first statement is correct and second is false. So let us go for the option 2 for this question. Now let me go to the next one. In the next one, the key shown in the circuit is closed at time t is equal to 0. So just when the key is closed, it is a growth of CR circuit. In CR circuit, initially current is maximum and current varies as I is equals to V naught by R and e power minus t by RC. I think by applying Kirchhoff laws, we will do the derivation. I think you know that. So when time is 0, current is maximum. So current in the circuit is maximum just at the initial condition. He said at t is equal to 0. So initial condition, current in the circuit is maximum. One option is correct. And current in the circuit initially 0, not possible. And voltage across the capacitor is minimum. Initially when time t is 0, the capacitor has no electric charge. So potential difference between two plates of the capacitor is 0. And here we can't say whether it is minimum or maximum from this condition. Let us go for the next one. Voltage across resistance is maximum. When electric current is maximum, potential difference across R will also be maximum. But here a current should travel from second plate of capacitor to battery at this condition, maximum current. So here among all these, most appropriate best option is current in the circuit is maximum. Here potential difference across resistance and across capacitor, we are not sure about that. So I prefer the best option is 3 for this question. Let us go to the next one. For the next question, a uniform solid sphere of mass m rolls down from rest to achieve speed v1 on an inclined plane of 30 degrees angle, and sphere achieves a speed v2 on an inclined plane of angle 45 degrees when released from same height. So when it is released from same height, let us check it. Here imagine this is an inclined plane making an angle theta. When height of the inclined plane is m, if a solid sphere is released from this point and if it is rolling without slipping, it reaches the ground while rolling. So in rolling, it is having a kinetic energy due to translatory motion half mv square and a kinetic energy due to rotation half I omega square. Moment of inertia of the sphere is 2 by 5 mr square, and when it is rolling half I omega square, and when it is in rolling motion, the velocity of center and r omega both are equal because inclined plane surface is fixed. So r square omega square I can replace with v square. When you add from all these conditions, the total kinetic energy of the sphere will be 7 by 10 mv square. Here when it is coming down, there is no work done by friction because the contact point always remains stationary relative to inclined plane. So though inclined plane will apply a friction on it, no displacement of contact point. So work done by friction 0. Hence there is no loss of energy. Hence the total decrease in gravitational potential energy converts into kinetic energy. That is, the decrease in gravitational potential energy mgh minus 0 is equal to increase in kinetic energy of the sphere. Final kinetic energy 7 by 10 mv square minus initial 0. So from this, here velocity of the sphere is depending only on height but not on angle made by the inclined plane. In the two cases, height of the inclined planes are same, only angles are different. So for same height, for same similar type of spheres, then the velocity with which they reach bottom will be same. Hence v1 and v2 are equal. Hence we can say that v1 over v2 is equal to 1. So this is the solution for the problem. Let us go to next one. Here the ratio which we can say it is 1:1, and let us go to next one. In this question, find the equation of magnetic field for the given equation of electric field for the electromagnetic wave. So there is an electromagnetic wave moving, and in electromagnetic wave, electric field vector, how it is varying depending on time is given. This is cosine omega t minus kz, means this is the equation of electromagnetic wave moving along positive z axis, and the direction of electric field vector is in ij plane 4i minus 3j. In general, when an electromagnetic wave is traveling along z axis, the direction of velocity of the electromagnetic wave vector will be perpendicular to electric field vector and magnetic field vector. Here electromagnetic wave is moving along z, so electric field and magnetic field should be perpendicular to z. Here electric field is in xy plane, then magnetic field should be perpendicular to z and should lie in perpendicular to electric field. The three vectors are mutually perpendicular. So from this, as you check, when two vectors electric field and magnetic field are perpendicular to each other, here their scalar product will become 0, because E bar dot B bar is equals to magnitude of EB cosine 90, and scalar product of E bar and B bar will become 0. That option is available only in the third case. You see 3i minus 4j, so 4 3s are 12 minus here minus 3 and minus 4, I think both are negative, so this is not possible. Let us go to next one. Here if I go to the next one, here you see in the first option 4 3s are 12 minus 3 4s are 12. Scalar product of E bar and B bar vector will be 0. But the thing is, here the relation between magnitude of electric field and magnitude of magnetic field is E is equal to BC from the concept of electric field. So the magnitude of magnetic field should be E over C. That is, he given it as E naught as it is, and so every term E naught is there divided by C is there, remaining the magnetic field magnitude multiplied by electric field amplitude when you check them, the two vectors, amplitude of magnetic field vector and amplitude of electric field vector, they should be perpendicular. If I check here the scalar product, if I go 4 3s are 12 minus 3 4s are 12, 0. So I am getting coincidence with here, whereas in second is not possible and in the other cases not possible. So I will go for the option 1 here, because phases of electric field wave and magnetic field waves are same and both travel in same direction, and amplitude of magnetic field vector is perpendicular to amplitude of electric field vector, and if this is E naught and magnitude is root over 4 square plus 3 square, that is 5. So if it is 5 E naught, its magnitude is 5 E naught over C. So it is coinciding. That is why I will go for option 1 for this question. It is completely based on the concept. Now let me go for the next question. The self-inductance depends only on geometry and on medium. Here self-inductance, I mean in general, if you check, this concept is from, for example, if there is a small circular ring and if an electric current I is passing through the small circular ring and the radius is very small, area will be very small, then because of this current, approximately a magnetic field B produces in the ring, that is mu naught I over 2R, and then magnetic flux through the ring is phi is equal to, when it is very small, the variations in B you can neglect. So flux through it is magnitude of B bar dot area vector. Here when current is traveling in this direction, B bar will be outside. If I take area vector also outside, then this is equal to B into area into cosine 0, and B is mu naught I over 2R, cosine 0 is 1, area is pi r square. Here from this we can say that the flux is equals to directly proportional to current, and flux is equal to a proportional constant L into I. So the L is here, if I compare the two expressions, that is mu naught pi r by 2, because one r will be cancelled here, and like in the place of current, here current is there and both are equal to flux. So mu naught pi r by 2, r is radius of the sphere, that is depending on geometrical dimension, and mu naught magnetic permeability. If it is vacuum in the space, you are getting mu naught. If there is any other medium, then the permeability of medium we have to write. So it varies depending on nature of medium and also geometry. So geometry and nature of the medium, that is geometry and property. So I will go for option 3 for this question. It is also based on the simple concept. And let us go to the next one. For the next question, you see in this question here is given a simple electric circuit, but here diode is also added to the circuit, and this diode, if you check, the A end of the diode mostly connected towards high potential side and B end connected towards low potential side. So if electric current is passing from high potential side to low, so current is coming like this, and here the current should divide. So this diode is in forward based condition. Here no resistance for the diode is mentioned, so I will take the case of ideal diode. For an ideal diode, you can neglect the resistance of the diode. So in an ideal case, when diode resistance is 0, that means I can replace this with a conducting wire of 0 resistance. So it behaves like that. Now the circuit will be a 4 ohms resistance and an electric current is traveling through this. Now here A and B are similar potential because potential difference across these two is negligibly small, because when diode is conducting in forward bias, the potential difference when a current is passing through it, you can take it as very small, or ideal diode resistance is 0, potential difference 0. You can select that. According to that, here 4 ohms are connected between A and this point and B and this point. These two are same potential, and nearly A and B are same potential. So 4 and 4 are in parallel combination. When they are in parallel combination, the equivalent resistance will be R1 R2 over R1 plus R2, that is 4 into 4 by 4 plus 4, that is 1. 4 4s are 16, and this is 4 plus 4 8. So we are getting 2 ohms. So resistance of this combination is 2 ohms, and this is 4. See here, after 4 2 ohms. So 4 ohms and 2 ohms are one after the other. They are in series combination. 4 ohms and this equivalent resistance 2 ohms, they are in series combination. So 4 ohms plus 2 ohms, total equivalent resistance will become 4 plus 2, 6 ohms. And if I write the same circuit, a 12 volts battery and a wire of resistance 4 ohms, 4 and 4 are in series, equivalent resistance is 2 ohms. So 4 plus 2 is 6. So current passing through the battery will be from the delta V equal to IR relation. I can write it as potential difference 12 is equal to current multiplied by equivalent resistance 6. So the electric current passing through the battery will be 12 over 6, that is 2 ampere. So a current of 2 ampere is passing through the battery. Here current in ammeter, whatever the current passing through the battery, that should pass through ammeter. So current in ammeter will be 2 ampere. First option is okay. And net resistance is 8 ohms. We are getting net resistance 4 plus 2, 6 ohms. So second option is incorrect. Voltage across B and C. Here 4 ohms equal resistors are connected between this point and this. They are in parallel combination. Because equal resistance are connected for same potential difference. So I1 R1 equal to I2 R2. Potential differences are same. And I1 R1 equal to I2 R2 in that condition, when potential differences are same, R1 R2 resistances both are also same. So same current should travel. Here current passing through ammeter, we calculated it as 2 amperes. So the 2 amperes should equally divide. So 1 ampere from 4 ohms and 1 ampere from 4 ohms. Then voltage across B and C will be, if you check it, through B and C, 1 ampere current is traveling. So potential difference between B and C is equals to IR. Current is 1 ampere, resistance is 4 ohms. So this will be 4 volts. And voltage across B and C, 4 volts is correct option. Current in ammeter 2 amps is correct option. Let us go to the next one. Current through the diode is, here 2 amperes current is coming and 1 ampere passing through diode through this, another 1 ampere is this. So current through the diode is 1 ampere. This is also correct option. So here A, C, D we are getting correct. Let us check in the options. A, C, D are correct. So coinciding with the second choice. A, C, D are correct for this option. Let us go to next one. Here find the time period of a cube of side length 10 centimeter. So it is a cube of side length 10 centimeter and mass 10 grams, oscillating in water. Density of water is given 10 power 3 kg per meter cube and G is 10 meter per second square. Here length of each side of the cube is 10 centimeter. Then what about the area of cross section of the cube? Suppose if the cube is like this, immersed in water and up to some portion of the volume is immersed in water, then gravitational force mg will act on the cube, some buoyancy force F will act on the cube. Now it is in equilibrium. Then if I push the cube for a small displacement x inside, because container volume is not given, we select the container very large. So approximately liquid level will remain same and cube is extra moved inside the container. Then the volume of the cube inside the container will increase. This will increase buoyancy force. So when you push it by a distance x down, then buoyancy force is more, and buoyancy force is more than the initial condition. Initially when it is in equilibrium, the initial buoyancy coincides with mg. Extra buoyancy when it is pushed x down is that x multiplied by the area of cross section. This is the extra volume immersed multiplied by density of water into acceleration due to gravity. And this extra buoyancy force is acting in upward direction, which is opposite to displacement x. If displacement x is in positive direction, then the extra force will be in opposite, that is negative direction. So that will be the extra force acting on it. And from this condition, here what will be the acceleration? If I take x multiplied by here minus x multiplied by, if I take area of cross section as capital A, density of water rho W into G, then the acceleration will be equals to net force over the mass, that is A, area of cross section, density of water rho W, G minus multiplied by x divided by net force over mass. So this will be the acceleration of the cube. This is coinciding with the condition of simple harmonic motion, x equal to minus omega square x. So in comparison, we can say that omega square is equal to area of cross section multiplied by density of water into G over M under square root. So area into density of water into G over M under root. And let us go for that calculation. So omega is equals to under root of area of cross section. Length of each side is 10 centimeter, that is 10 by 100 meter. So area will be length of each side square, L square, and area of cross section multiplied by density of water 1000, and acceleration due to gravity 10 divided by mass of the cube, and omega is 10, so we are getting pi by 5. We have to check about the data here. Length is 10 centimeter as it is. Maybe in the mass, maybe in the memory they have given a different idea, but for this I am getting the time period like pi by 5. So this is the way of calculation for this. And let us go for the next one. For the next question, adiabatic constant of a gas is 3 by 2 given, that is gamma is 3 by 2. So it is mentioned. And volume of gas initially at 0 degree centigrade is reduced to 1/4 of the original volume, then new temperature. Means at 0 degree centigrade, if the volume of the gas is V, then at what new temperature T, volume of the gas will reduce to 1/4 of initial value. So gamma is 3 by 2, and initially temperature 0 degree centigrade. If I convert this into Kelvin, 273 plus 0, I am writing approximately. So 273 plus 0 is 273 Kelvin. That is initial temperature corresponding to 0 degree centigrade. And let me go for the solution of this. Here, the relation between temperature and volume in adiabatic process is Tv power gamma minus 1 will remain constant. So initial temperature T1, V1 power gamma minus 1 should equal to final temperature T2, V2 power gamma minus 1. Initially it is at 273 degree centigrade, 0 degree centigrade. So 273 Kelvin, volume V. Here gamma is 3 by 2. So 3 by 2 is gamma, then gamma minus 1 is 3 by 2 minus 1, that is 1 by 2 we are getting. So initially V gamma minus 1 is 1 by 2. We don't know final temperature T2, and volume is reduced to 1/4 of initial, and finally gamma minus 1 is 1 over 2. Then what we can write is V power 1 by 2 we can cancel in both the sides. 4th to the power 1 by 2 is square root of 4, that is 2. So 273 over 1 is equal to T2 by 2. Then T2 is 2 into 273 in Kelvin, that is 273 into 2 is 2 into 200 is 400, 2 into 70 is 140, 2 3s are 6, so 400 plus 140 plus 6, so 546 Kelvin. This will be the final temperature of the gas. And let me check this in the solution, in the question paper. So 546 Kelvin it should be, not in centigrade. If it is in centigrade means again we have to convert from Kelvin to centigrade. In centigrade it is 546 Kelvin minus 273, that is 3, and this is 7, and this is 2. So in centigrade it is 273 degrees centigrade. So option is 546 Kelvin for this question. Now let us go for the next one. For the next question, two objects are equal distances from sphere of radius r and refractive index mu. That means here there is a sphere, of radius r, and the sphere is placed in air and an object is placed at O. Then light rays traveling from the object entering from air into the sphere of refractive index mu suffer refraction, and after refraction they finally focus somewhere at point I, suppose. So light rays should travel and meet at I to get an image. See, two objects are at equal distances. If I imagine this first object is at a distance u, then another object is placed on the other side at the position of I at same distance u. So that image of I will focus at O and image of O focus at I. That is the meaning of this question. Just check it. The two objects are at equal distances from a sphere of radius r, refractive index mu, such that image of one object forms on the other object. So image of O forms on other object I and image of I should form on other object O. This is possible when the light ray passing through the sphere should be parallel. Then only here for object here the image is at infinity. Similarly, the object here image will be at infinity. Then only there may be a coincidence. So from this condition, we can say that if I consider the refraction at the first surface, here final image should be at infinity. That means for the first refraction, I go for image is at infinity and object is at u. So we have to calculate object distance u. I go for refraction at first curved surface. Here light rays traveling from my left hand side to right hand side. So this is negative and this is positive according to geometric sign convention. Now let me solve this. Here the refraction at curved surface is according to relation mu2 by v minus mu1 by u is equal to mu2 minus mu1 over r, and here final image is at infinity. So image distance will become infinity, means mu2 by v will become 0. U on negative side and mu1 is air. So refractive index 1, u on negative side minus u minus of, and here mu2 second medium is sphere and first medium is air because light traveling from air to sphere. And for the sphere, when light rays are traveling like this, the center of curvature of this curved portion lies here. So radius of curvature will be on positive side. So I will go for r positive. And here 1 by u is equal to mu minus 1 by r. Then the object distance will be r over mu minus 1. Here by imagining that after first refraction the light rays will be parallel, with this logic I got this solution. I am not checking the total. Here checking the total will kills more time, but from this you can go for the object distance as r by mu minus 1. And let us check the question. Here in the question r by mu minus 1 option is available. And let us go to the next one. There is force field. That means there is a field and that field will apply force. So there is a force field and the force acting on the particle when it is at x coordinate x, y coordinate y is given there, and particle is moving along the line x is equal to y. So line x is equal to y, I mean y is equal to x, that is y is equal to 1 into x. So slope is 1 means theta 45 degrees. So along this line particle is traveling. When particle is traveling, the variable force is acting on it. Because force acting on the particle is variable, work done by the force on the particle will go like integration of force vector dot displacement vector, that is fxi plus fyj plus fzk dot dxi plus dyj plus dzk. So I will go for this as integration of f of x dx plus integration of f of y dy, and f of z is not existing, so integration of fz dz doesn't exist. Here force x component is x cube y. So here force x component is x cube y. Let me check that. The work done by the force is integration of, let me check it once again, x cube y is x component and y square is y component. So x cube y dx plus integration of f of y dy is y square dy, and the particle is traveling from 0 0 position to 2 comma 2 position. So 0 0 position to 2 comma 2 position. Here dx, x varies from 0 to 2, and dy, y varies from 0 to 2. And y is equal to x is the locus equation of the path. So I replace this y with x. Then the work done will become integration of x cube y means x cube multiplied by x. I can replace y with x from this relation into dx, whereas x varies from 0 to 2, plus integration of y square dy, and where y varies from 0 to 2. So x power 4 by, this is integration of x power 4 dx. So x power 5 by 5, applying limits, 2 power 5 by 5 minus 0 power 5 by 5 plus y cube by 3, we will get integration of y square dy, that is 2 cube by 3 minus 0 cube by 3, and after solving you will get the solution. I am leaving the calculation to you. Let us go to the next one. So this question is from radioactive decay. Actually the rate of decay, half-life, mean life are not there in the main syllabus, but don't know how it was given. Maybe given or maybe by mistake may student given this idea, but most of the students are said that this is the question we are getting. Let us do this also. In a radioactive decay, decay constant of element A2 is 3 times the decay constant of element A1. Radioactive decay constant, that is disintegration constant, for element A2 lambda 2 is 3 times to element A1 lambda 1. And find the ratio of nuclei of element 1 to element 2. So here find the ratio of nuclei existing in the form of element 1. That means number of undecayed nuclei which remain in the form of element 1 to the number of undecayed nuclei which remain in the form of element 2. N1 by N2 is asking that ratio after one half-life of A2. So after half-life time of A2, that is second object, this is logarithm base 2 divided by lambda of A2. So up to this time or at this instant of time, we have to calculate the ratio of the nuclei and assume that initial number of nuclei are same for both elements. So here, as we know, the number of undecayed nuclei will become equal to number of initial undecayed nuclei n naught e power minus lambda t. I use this condition. According to that, n1 will become n naught e power minus lambda t1 and lambda 1 t, and for second one is n naught e power minus, for second element lambda 2 t. We have to calculate this ratio after same time, which is half-life of the second object. And initially number of undecayed nuclei, assume that they are same given. So n naught we can balance. Then the ratio will be equal to e power minus lambda 1 t over e power minus lambda 2 t. If I rearrange this, this will go to numerator e power lambda 2 t. So lambda 2 minus lambda 1. So exponential of lambda 2 minus lambda 1 into t. This will be the ratio whatever he asked. So the ratio is e power lambda 2 minus lambda 1 into t. One hint given is lambda 2 is 3 times to lambda 1, and another int is the time is log base 2 by lambda 2. So let us go for the solution board. Here the ratio is number 1 e power lambda 2 minus lambda 1 into t. So the ratio is e power lambda 2 minus lambda 1 into t, one condition. And second condition, if you check it, lambda 2 is 3 times 2 lambda 1. So lambda 2 is 3 times 2 lambda 1. Hence the ratio will become equal to e power 3 lambda 1 lambda 2 minus lambda 1 into t, that is e power 2 lambda 1 into t. And here this time is the ratio n1 by n2 is this much, and this time is half lifetime of second object, that is log base 2 over lambda 2. So let us substitute the time there. The ratio will become equals to, sorry, this is plus 2 lambda 1. So the ratio will become equals to e power 2 lambda 1 into t is log base 2 over lambda 2, and lambda 2 is 3 lambda 1. So this is e power 2 lambda 1 log base 2 by lambda 2 is 3 lambda 1. Lambda 1 will be removed. Then this is equal to e to the power 2 by 3 ln base 2, and this we can write e to the power log base c 2 to the power 2 by 3. E power log base c 2 is 2 only. So this is equals to 2 power 2 by 3. So this will be the answer for the question. And let us go to the next one. So 2 power 2 by 3 we are getting here. Let us go to the next one. In this question, infrared light of wavelength 900 nanometer used for muscle pain. Which of the following transition in hydrogen atom can be used? In hydrogen atom, Lyman series is in ultraviolet, here in normal Lyman series, Balmer series, Paschen, bracket and Fund. We are going like this. So this will be in infrared region, very less. Sorry, when light travel from 2 to 1 and 1 minute. Let me check it. Okay, let me go for this question. Here we have Lyman series, Balmer series, Paschen series and bracket and Fund series. If you check the table given in NCERT textbooks, the Paschen series from infinity to 3 will coincide with this region of wavelength 900 nanometer. Just directly from theory, the when electron shifts from 3 to 1, 5 to 2, energy of the electron in hydrogen atom is minus 13.6. For hydrogen atom, Z is 1 over n square. So E2 minus U1 you can subtract for different values of n and you can check it. So simply basically depending on theory, I leave this for you. And let us go for next question. ఇంకెక్కడ ఇది అయిపోయింది, ఇది రైట్. So for this question, if you see here, a uniform circular disc of radius 20 centimeter, it is a small circular portion of radius 5 centimeter is removed, then shift in the position of center of mass. So from the total circular disc, a small portion is removed. When we add some particles m1x1 plus m2x2 and so on, when we remove the particles, because mass is removed, we select like m1x1 minus m2x2 and so on. Here first let me check. Here the cavity thickness and original disk thickness will be same, density will be same. So mass directly proportional to area because density and thickness are same. So the mass of the original circular disk will be the constant multiplied by area of the disk is pi into its radius 20 centimeter whole square. If this mass is m, then mass of the cavity portion m1 should be same constant pi and radius of the cavity portion is 5 centimeter square. So here if you check this, the original mass of the disk will be equals to k pi multiplied by 400 times nearly, and this is k pi multiplied by 25 times. So that is, it is original mass divided by, here 400 divided by 8 will be 25 because 400 divided by 4 is 100 and one more 4 is 4 ones are 400s and 4 ones are 425s. So 400 by 16 will become 25. So if I write this as m by 16, that will be 25, that will be same as m1. So I can write m1 as m upon 16 because its area is a constant into 25 and total disk area will be a constant into 400. And 400 over 16 is 25. So m over 16 will be this much. So cavity portion, I can imagine a circular disk of mass m by 16, whereas original circular disk, if I imagine original circular disk mass is m, then cavity portion circular disk will be m by 16. Now from this, let me go for the solution for this part. Here from the circular disk, this original circular disk radius is 20 centimeter. And from this we have made a cavity and this cavity radius is 5 centimeter. Let me take the original circular disk geometric center as origin. Then the original circular disk mass is m, whereas the mass related to cavity portion is m over 16. So from m over 16 we have to remove. Then what will be the x coordinate of center of mass? That we can write it as m1 x1 and m2 we have to remove, so minus m2 x2 divided by, here this is m1 x1 so m1 x1 minus m2 x2 divided by m1, we are removing m2, so minus m2. And what about x1? Here total circular disk center of mass will coincide with the origin, so x1 will become 0. And x2, that is the center of this cavity portion. Center to this edge is 5 centimeter and origin to this edge is 20. Then distance between these two will become, from total 20 remove 5, you will get the distance between these two, that is x coordinate of cavity will be 15 centimeter. So x1 is 0, x2 is 15 and original mass m and removed cavity portion is m by 16. So let us go for the calculation. The x coordinate of center of mass is equal to, m1 is m, its center of mass is at origin 0 and cavity portion is m by 16 and its center of mass is from origin at 15 centimeter divided by m minus cavity portion is m by 16. So in the numerator it is minus 15 m by 16. In the denominator 16 m minus m, that is 15 m by 16. So that is minus 1. Here if when I have taken the geometric center of the original disk as origin, new center of mass is minus 1. Means center of mass of the system is 1 centimeter to the left side of the center of the original disk. So let me check with the key in the options given. here it is in centimeters he mentioned, so an integer, and actually it will shift towards negative side, so we'll go for option as 1 centimeter for this. And let me go to the next one. A bullet of kinetic energy 125 joules strikes a lead block where temperature rises by 50 degrees centigrade. That means when bullet is moving and collides with the lead block, the loss in kinetic energy of the bullet because of the resistances forces applied by lead block on the bullet is converted into heat energy. That heat energy either absorbed by the bullet or absorbed by the lead block or absorbed by anyone. Here specific heat of lead is given, mass of lead block is assume that half of he is asking what will be the mass of the lead block. Okay, he is saying that only half of the kinetic energy of bullet is converted into heat. Here the specific capacity of lead is given, that means this heat energy absorbed by lead only is mentioned. So what we can find out is the loss in kinetic energy of half of kinetic energy of the bullet, that is half of half mv square. This kinetic energy of the bullet might be converted into heat energy and which is absorbed by the lead. And because of this, what we have to find out, its temperature is increasing by 50 degrees centigrade. Only change in temperature, no change in state. That is why we can write it as mass of the lead bullet multiplied by specific capacity of lead multiplied by change in temperature. Here this mass is mass of the lead block absorbed by it. So it is the mass of the block, and this is mass of the kinetic energy of the bullet. Here instead of mass of the bullet, total kinetic energy given as 125 joules. So I can take this as 125 multiplied by 1 by 2 is equals to, and mass of the lead, that is only is asking us, so m, and specific heat is given 0.1 joule per gram per centigrade, delta T given 50. You can substitute the values, a simple calculation. So I am leaving the calculation to you. Here specific heat multiplied by change in temperature. Only the thing, remembering specific heat, it is given 0.1 joule per gram per centigrade. Then if you check the units, that is 125 over 2. This is kinetic energy. Half of the kinetic energy, it is in joules. This is equal to mass of the bullet, and specific heat is joule per gram per centigrade, and temperature change is 50 degrees centigrade. Here you see centigrade will cancel, joule will cancel here both sides. Even 125 joules, joule both sides will cancel. So remaining is grams. If you substitute the specific heat as it is, you will get the mass in grams. And the mass will be equals to, m is equals to 125 upon 2, and here 50 goes to denominator, and specific heat capacity 0.1 here goes to denominator, and units are in grams, and 2 into 50 is 100, 100 into 0.1 is 10, and 125 by 10 is 12.5 grams. So this will be the mass of the bullet, and if it is nearest digit 13, and if integers are available up to third portion, we can go for 12.5. So this is the solution for this question. Let us go to the next one. In the next question, a positive ion A and a negative ion B have charges. So they given the charges, they given the masses, and ions are separated by a distance. Okay. At that instant, ratio of magnitude of electrostatic force to gravitational force. Here electrostatic force, as we know, it is Q1 Q2 divided by 4 pi epsilon naught r square, a simple theory, and gravitational force is G m1 m2 by r square. Just we have to calculate ratio of these two. Distance will be same, so r square will be same, and remaining is 1 by 4 pi epsilon naught is 9 into 10 power 9. Substitute q1, q2, g and m1, m2 values. You will get the answer for this question. So that's about this question paper here.